Today we're going to study area of parallelogram. For example, number 1, given the base equals to 14 centimeter and the height is equals to 8 centimeter, and we're going to find what is the area. Solution, we will use the formula. The formula of parallelogram, area equals base times height. Then we have to substitute. The given base is 14 times the given height is 8, and we're going to find the product. 14 times 8 equals 112 square centimeter is the area. Okay, that's the answer for number 1. And number 2 is a problem. A playground and the shape of parallelogram has an area of 110 square meter. What is its base if the height is 55 meter? Solution, again, we will use the formula of parallelogram. Area equals base times height. Then we have to substitute. The given area is 110 equals the base times the given height is. Then we have to multiply it. B equals B times 55 equals 55B, and the area, which is 110, just only bring down or copy. And then since we're computing for the value of B, we have to eliminate the 55 by dividing both sides by 55. So 110 divided by 55 equals 2. And 55 divided by 55 is 1 times B equals B. So the height now, the base now is 2 meters. Okay, the third problem. The base of a parallelogram is 50 meters and the height is 25 meters. What is the area of a parallelogram? So our solution, we have used the formula again of parallelogram. Area equals base times height, and we have to substitute. From the problem, the given base is 50 meters and for the height is 25 meters. And then we have to multiply 25 times 50, so the area now is 1,250 square meter. Okay guys, today we're going to study again solving trigonometry part 9. We are now in number 57. Simplify cotangent square theta minus 1 over secant square theta. So the first thing to do is our solution is copy first the question. Cotangent square theta minus 1 over secant square theta. Our first step is just copy this cotangent square theta because it's already simplified. But this 1 over secant square theta is not yet simplified, so we have to do is remember that if we have 1 over secant square theta, this will be equivalent to cos square theta. That is why our simplified for this given trigonometric expression, it becomes cotangent square theta minus cos square theta. Next, number 58. Find the sum of 3 over 1 plus sine theta plus 3 over 1 minus sine theta. The first thing you do is copy first for our solution. 3 over 1 plus sine theta plus 3 over 1 minus sine theta. And our first step is to find the LCD of this 1 plus sine theta and 1 minus sine theta. So we have to do is write parentheses and copy. Our target is to multiply this for our LCD. And then after knowing that this is the LCD, we're going to divide 1 plus sine theta and 1 minus sine theta divided by 1 plus sine theta. So this will be the same, so cancel. So the remaining is 1 plus sine theta. Multiply the numerator. That's why we have 3 quantity 1 minus sine theta. then plus, copy, then we're going to divide again this LCD from here. Okay, 1 minus sine theta, 1 minus sine theta, cancel this one. So the remaining is 1 plus sine theta times the numerator. So that's why we have 3 times quantity 1 plus sine theta. Then the next thing we do is to simplify. We're going to use the distributive property. 3 times 1 equals 3. 3 times minus sine theta, we have minus 3 sine theta. Then plus 3 times 1 equals 3. Then 3 times sine theta, so we have positive 3 sine theta. All over, we're going to multiply this. If we have positive negative, we can directly multiply this. 1 times 1 equals 1. Positive sine theta times negative sine theta, we have negative sine squared theta. And then we're going to combine like terms. 3 plus 3 equals 6. Then negative 3 sine theta, then positive 3 sine. We are going to cancel this, no more. Over, copy the denominator. And then we have sine over, we have 6 over 1 plus sine squared theta. Remember, this will be equivalent to cos squared theta. And then we have here 6 over 1 secant squared theta, the equivalent of cos squared theta. Then the reciprocal of that becomes 6 times secant squared theta over 1. Then we're going to multiply 6 times secant squared theta equals 6 squared theta over 1. So this will be our final answer, 6 secant squared theta. Okay guys, we are now number 59. We're going to answer this question. Find the difference of 2 over 1 minus tangent theta minus 2 over 1 plus tangent theta. So our solution, we're going to find first the LCD of this denominator because the denominators are not the same. So therefore, we're going to multiply 1 minus tangent theta to 1 plus tangent theta. Then we're going to write at the left side of the equation, we have 2 over 1 minus tangent theta minus 2 over 1 plus tangent theta equals 2. You have to do right first the division line, and below the division line, we're going to write the LCD. Our LCD is 1 minus tangent theta, quantity 1 plus tangent theta. So we need to see we're going to multiply this. But before we do that, so we're going to divide this LCD, divide the denominator of the first expression. So that's why we're going to cancel this one. The remaining is 1 plus tangent theta, then multiply it to the numerator. So that's why the result is 2 times 1 plus tangent theta. Okay, then next, since this is minus, we have here minus sign. Then the same process, we're going to multiply and divide this LCD, so the denominator of the second expression. Then we are going to cancel, so the remaining is 1 plus tangent theta multiplied to the numerator. That's why the result is quantity 1 minus tangent theta over, so we're going to multiply now the denominator. 1 times 1 equals 1. Then directly, because this is negative and positive, so we can do the direct multiplication. So that's why negative tangent theta times positive tangent theta, we have negative tangent squared theta. Then the numerator, now we're going to simplify, equals 2 by distributive property. 2 times 1 equals 2. 2 times tangent theta, we have 2 tangent theta. Then minus 2 times 1 equals minus 2. Then negative 2 or minus 2 times negative equals positive. Then 2 times tangent theta, we have 2 tangent theta. Then we're going to simplify, combine like terms. So we have 2, negative 2, so cancel, no more. And we have here 2 and 2, we have 4. Tangent theta, just only copy. No squared because we're just only adding the two tangent expression, we're not multiplying. That's why there's no, the exponent is the same one here. All over 1 minus tangent squared theta. Then this time we have a take note here, if we have cotangent squared theta, this will be equivalent to 1 minus tangent squared theta. But in here, in our denominator is 1 minus tangent squared theta, so therefore our denominator should be cotangent squared theta. That's why our final answer is 4 tangent theta all over cotangent squared theta from here, from this expression. Okay, we are now number 60 problem. Simplify 1 plus tangent theta over 1 plus cotangent theta. Our solution, you have to copy first the question. 1 plus tangent theta over 1 plus cotangent theta equals to, we're going to, our first step is to conjugate the denominator. So we have 1 plus cotangent theta, the conjugate of this is negative 1 negative cotangent theta. Our first step is to copy first the question. 1 plus tangent theta over 1 plus cotangent theta. We have to multiply to the conjugate of a number, so we have all over 1 plus cotangent theta. The conjugate of this is 1 negative cotangent theta, and the numerator is also the same, 1 minus cotangent theta. Our next step is equal to, we're going to rewrite a division line here, and we're going to multiply the numerator directly to the numerator of the other side. So 1 times 1 equals 1, positive times negative equals negative, tangent theta times cotangent theta is equals to tangent theta and cotangent theta. All over, we're going to multiply also the conjugate. 1 times 1 equals 1, positive times negative equals negative, and cotangent theta times cotangent theta is equals to cotangent theta squared theta. And then take note that if we have tangent squared theta, cotangent squared theta is equals to 1, and if we're going to transpose the cotangent squared theta to the other side of the equation, so we will have the tangent squared theta is equals to 1 minus cotangent squared theta, which is equivalent to the denominator, which is 1 negative cotangent squared theta. So therefore our final answer is equals to 1 minus tangent theta cotangent squared theta. Just only copy the numerator, and denominator we're going to change to tangent squared theta, because this 1 minus cotangent squared theta is equivalent to tangent squared theta. That's why our denominator final answer now is 1 over tangent theta cotangent theta over tangent squared.